Yeah, do we want to start with a quick intro so people know who's here? Guillaume, do you want to start?
Okay. So my name is Guillaume. I'm located in Lausanne, Switzerland. It's 3 p.m. my time. I'm the engineering manager for the search platform team at Wikimedia Foundation. Despite the name of the team, yes, does do some work on search, but also a lot of work on Wikidata Query Service and Wikimedia Commons Query Service and a few other query service and structured data and RDF stuff. I've been with the foundation for almost 6 years, and I think that's about all for me. David, you want to go next?
Sure. Hi, I'm David. I live in France. I'm a software engineer for the search platform. I work mostly these days around maintaining Wikidata Query Service. And I do also a bit of search, especially the one you use on Wikidata. And I think that's about it for me. Next, Aisha.
Hi, I am Aisha Khatun. I live in Bangladesh. I am a data analyst for the search platform. I've been here less than a year, I guess almost a year in December. So my work is revolves around finding information and insights that will help us solve the challenges related to scaling Wikidata. That's what we're talking about today. Zbyszko.
Hi, I'm Zbyszko. I'm a software engineer in the search platform team in Wikimedia Foundation. Mostly working on Wikidata Query Service, sometimes on search as well. Been with the foundation for the last 2 years, minus a month, more or less. I know that Guillaume really wants to keep this precise, so it's a year and minus a month and 9 days. I think I come from Poland. I come from Poland, from the coastal city of Gdańsk. I don't have anything more interesting about me to say, so I'll pass on to Lydia.
Yeah, hi, I think most of you know me. I'm Lydia. I do the product management for Wikidata. I work for Wikimedia Deutschland, and I brought Adam with me.
Hello, and I'm Adam, and I'm in the UK, not in Germany, even though I work for Wikimedia Deutschland, and I'm the tech lead for Wikidata and Wikibase. I think I've been around here for about 6 or 7 years now, but I've started to lose count, and I've nearly finished my coffee.
All right. Guillaume has a question which is unrelated to the query service. But if anyone knows the shortcut for muting, unmuting, and big blue button, that would be helpful. Otherwise, let's get started with actual questions about the query service. Do you have some? You can post them in the chat.
I see 7 people perusing the slides, so that's a good sign.
Question from TPT: do you have any plan for WCQS? And yes, we do. We are working at the moment on moving WC. So for people who don't know, some minor context, WCQS is the equivalent of WDQS. So it's a Sparkle endpoint, but backed by the data on Wikimedia Commons. At the moment, we have a service in beta. It's running on Wikimedia Cloud Services. The data is reloaded weekly, which is obviously a problem for anyone who wants fresh data. It's a beta service. It crashes every now and then, and it's not well supported. We have planned to move that to production hardware in the next quarter. So the hope is that we're going to do that by the end of this year. There's some work to do, but that's the plan. David and Zbyszko can probably go into more details about what this is going to entail. The main difference between the current service and the service as it will be in production, is that we will have live updates streaming from Commons. So we're going to get rid of that weekly data reload and have fresh data. Otherwise, it should be roughly the same. It's the same kind of hardware behind it. So yeah.
I want to add a single thing about this because I know this has been a point of contention for some people. Wikimedia Commons Query Service is behind the authentication. I know that right now it's somewhat broken on beta, but we decided since we are moving into production now, we will focus on production this particular moment. Third, we plan different solutions for authentication in the future, but after the experiences with Wikidata Query Service, it was clear to us that we need some sort of a gateway to be able to better handle traffic than we did on the Wikidata Query Service. That's it.
So maybe one of you can talk a bit about why this authentication is needed. So for example, that we have some very heavy users.
Yeah, you want to go on, Zbyszko?
No, I can gladly concede.
Okay. Yeah, one of the recurring problem on Wikidata Query Service is that one user or bot or user agent or one entity is starting to generate enough traffic or enough complex queries that they can fairly easily take the whole service down. And Wikidata Query Service doesn't have any kind of authentication, so we're the only way we can identify the source of those queries is going through the logs, parsing user agents and IP addresses. But that breaks down in a lot of cases, like someone running a distributed bot on AWS, and suddenly the only way to stop that is to ban all of AWS IPs, which is obviously not a great idea. It's also making it much more difficult to understand who is doing what in terms of having a better understanding of the kind of use cases we have on the system. It's always very hard to add authentication after the facts because people have built stuff on the endpoint. So if we were to add authentication on WDQS at the moment, it would break a ton of use cases and it would need a lot of work. So we want to start in a safe position with WCQS and then look at how we can improve it, change it. The goal is very much not to restrict access. You need to have a user account on Wikidata or Commons, which is easy to get, and there's no intention to restrict access more than requiring some kind of authentication. Yeah, rate limiting is another thing that's much easier to do. If you have authentication, then you can limit per user. We have some kind of heuristic at this point based on user agent and IP address so that we can have some kind of rate limiting, but it's very limited as long as we're not able to identify a user.
I want to add one thing into this. This is not the final solution we're going to go with. We don't know when or how. Sorry, not when. How we do actually know. But there is a general solution that is being developed right now for Wikimedia services. I think the name API Gateway is somewhat of a temporary name. I'm not sure. That will allow all the services hosted by Wikimedia to use authentication in a non-interactive way using OAuth2 flows and allow a more custom approach when it comes to rate limiting for logged and non-logged users. This is probably far in the future, but we are looking at it at the moment as well.
Yeah. Peter is asking if federating is the general solution. Maybe one of you can go into this, but before that, one thing that is very clear based on all the work we've done together now is that there is not one solution, right? There is not one thing we can do to make things better and fix things, right? There's going to be many different things that are tackling part of the problem. But yeah, so how about federating? Anyone want to talk about that?
So federating means a lot of things in different contexts. So clearly, the way we're using Wikidata and Commons, or the structured data on Commons together, is through federation. And that's something that makes a lot of sense in that context, because the structured data on Commons is already separated from the Wikidata graph itself. That's interlinked. They take advantage of each other, but they are stored in different wikis. There's a clear separation between them. So in that case, like, federation is a no-brainer. That totally makes sense. We already have two graphs as an input, and then we have two Sparkle endpoints that federates, and we're replicating that same structure along the way. And that makes sense. We could make a similar use case for Lexeme, which have a different namespace inside of Wikidata. So we already have two different graphs that are clearly identified, and it would probably make sense also to replicate that structure further down. If we go one step forward, we are worried that the current model of Wikidata, which is the single repository of all of the human knowledge, is not going to scale forever. And we're already seeing tensions around that model, where part of the graph, like the usual example is Scolia, but Lexeme could be another one, or part of that graph are already somewhat disconnected from the more general graph, and it might make sense to split it in terms of editing as well. So federation might be part of a solution to manage the growth of our knowledge.
So Peter is clarifying it meant, I just meant many Wikibases with different information and a query service that could reach them all. Adam, do you want to talk a bit about different Wikibases hosting content from Wikidata and additional content to Wikidata?
Yes, I mean, it's certainly something that's been on the up and up in the last few years, is the number of Wikibases with their own specific data sets. That probably isn't going to dramatically solve too many of the sort of concerns that we have, really, because most of this is totally new data that doesn't already exist in Wikidata. There's always been this discussion around whether or not things like bibliographic data should end up in their own Wikibase. That certainly makes up a fairly, I don't remember the numbers, but it makes up a fairly large proportion of the graph that is on Wikidata. But right now, all of the other Wikibases are just sort of adding to the number of graphs that we can build connections between, really. And in terms of, I've lost where it was written. But yeah, in terms of federating queries, all of these Wikibases can already make queries between all of their respective query services. So that's already possible between their query services.
All right, we had one question from Toby earlier around the authentication. Maybe we can go back to that. How will web tools gain access? For example, browser extensions or dynamic websites. Does the creator need to take responsibility, or the person running it?
I actually responded to this on the chat, but in general, the only thing that the thing that is required is that user has to log in. If user is logged in, they will have a proper session cookie, and this should work unless the tool is built in a way that doesn't pass those cookies further down the road. But in generally, should work. I haven't seen an example. I haven't worked on one, so I cannot guarantee at this point that is what the situation is. But in general, I would recommend, if writing something like this, to reach out to ask to see on a specific concrete example, see if see what might be the problem, if there is a problem. And I know that already some people have written some bots that operate on WCQS, so I'm guessing it is possible. And I am aware of the fact that what we are proposing right now isn't super comfortable for usage. Unfortunately, we had to start with something, and we'll get this better down the road.
And then one of the next questions is, does the effort to scale Wikidata Query Service includes efforts focusing on improving the documentation and examples of other APIs? Currently, the Wikidata Query Service docs and examples are outstanding compared to the other interfaces, which makes it easier to use, even though it's suboptimal for many use cases. Yes, this is a very good point. So our tech writer is currently working on documentation that focuses on when should you even be using the query service, as opposed to some of the other APIs that we offer. But the problem is, for many of the use cases that people use the query service for right now, but probably shouldn't, we don't have really good alternatives. So the upcoming REST API we're going to work on is going to address some of that. And once we have that, that should, of course, have really good documentation so that people are going to be excited about moving to it instead of running these on the query service. Yeah. Does anyone else have comments on the documentation and other APIs topic? If not, then we have another question from TBT. What about providing two kinds of servers, one for simple queries with live data and responses, and one for big queries that might be only updated daily or weekly?
That's definitely something we have in mind. At the moment, updating the full graph daily or weekly is not something we're able to do. Like, updating from the dump is a process that takes more than a week. So it becomes difficult to do it every day, unless like you have a ton of servers doing nothing in the background, but just updating to get ready. So having different kind of servers depending on the need of the users is definitely something we want to think more about, but it's not clear that the simple solution of just increasing the delay between refresh is viable or is actually buying us anything within the current technologies that we're using. This might change in the future, but currently it doesn't seem to be feasible.
I think we missed one question as well.
Oh, did we? Sorry.
By Tom, but wait, I've just lost it. Yeah, okay. Tom, could entity schema help split the data if splitting is needed? I think that's definitely an interesting thing that could help. I think this ties in a lot with the whole idea of subsetting and the discussions around subsetting that are happening with Wikidata, because one of the problems of coming up with arbitrary ways to just carve Wikidata in half is, if you look at bibliographic, like metadata and records around things like that, it's hard to say where to draw the line through that, because lots of these things people would consider do make up part of the normal side of the Wikidata graph, and lots of them though are sort of very specifically more sort of papers and things like that. And so entity schema could probably help, but I don't think there's really been too much discussion around that.
There has been a paper published, I think, just last week at the Wikidata workshop at SWC. Working on this, I haven't had a chance to look at it in detail. But to illustrate a bit of what said, what the problem is. So, for example, let's say someone wants a movie subgraph. do they just want items that are instance of movie or some subclass of it, or do they also want items for the actors, for the producers, for the countries where they were shot, and all these kinds of things? Is that part of the movie subclass or graph or not? It's messy, and the answer is probably different for different people who want the movie subgraph, which makes this interesting. But yeah, maybe checks can be a way to define that. Right, then we have a question from Lawrence. Can you give some kind of timeline of when you might be replacing Blaze Graph, or if that is even going to happen? Some potential Wikibase users are getting spooked about adopting because they hear it might be getting replaced soon, or not to be able to cope. Maybe it'd be replaceable for Wikidata, but still usable in Wikibase, like a pluggable backend.
We don't have any concrete timeline at this point. Like the best case scenario, if all the stars and planets align, is it's going to take at least a year and probably two before we have a transition to a different backend. And take that with all the pile of salt it needs. I'm taking that number out of hat. We don't even know what alternative backend there is, if there is one at this point. We are working on clarifying all that and seeing what's possible, but as for a concrete timeline, no idea. It is reasonable to get spooked at this point because yes, we're having problem with the current solution. So the problem we're having are mainly coming from the scale of Wikidata and the fact that it's a public endpoint used by a ton of different people all over the internet. In the more simple use case of a dedicated Wikibase for a dedicated use case with smaller data sets and a smaller community of users, I don't think Blaze Graph is going to be a blocking problem in the near future. Adam can probably say more about that use case than I can. But
yeah, I was just going to entirely agree with everything you said. Like if I was running a Wikibase, I probably wouldn't be concerned because I suspect most, if not all, Wikibases out there aren't going to be doing things on the same scale. And again, to just, as I've got the slides up in front of me, the scale that the Wikidata Query Service operates on right now is 290 requests per second. So, I mean, if your Wikibase isn't doing that, then it will probably work with far fewer issues. And again, in terms of updates, what was it? It's 330 triple updates a second. Is that a second? Yeah, I think. So it's the case of juggling all of that is what normally highlights the stresses with Blaze Graph.
I want to mention, if your Wikibase is doing that, please come to us and let's exchange experiences.
Yep, we want to talk to you in that case. Cool. Then a follow-up on a previous question. What about the linked data fragments endpoint, which should already be deployed? It would cater for simple queries and client-side computation.
Was it the question to us, for us?
yeah, so we do have an LDF endpoint. So the problem is the current implementation of this LDF endpoint is problematic in a number of ways. It's not an endpoint that can be balanced between multiple servers, so it's pinned to a single server. There's a single server behind that endpoint. If it breaks, then the LDF endpoint completely breaks. We don't have clear data on that. We know that there are people who are trying to, let's say, probably abuse that system and download like millions of triples through the LDF endpoint, and that doesn't work, which is expected. That's definitely something that we should make sure we have, or we should make sure we understand better what are the use cases that can go through that LDF endpoint and how much of the current load that represents or not. It's very much underused at the moment, and that's reasonable because the implementation behind it is far from ideal.
Yeah, so if you're using the linked data fragments endpoint, it would be cool to understand what exactly you're doing with it. Right, then Egon is asking, with the keynote yesterday in mind, if literature review references are removed, what governance will be put in place that the gap is not filled in no time with other data? That is, who will decide what comes after literature items to be split off?
I think I can give a bit of a context here on the amount of time it will require. So we calculated kind of a very wide approximation of how long it would require Wikidata to come back to the current size. And since scholarly articles are like 50% of Wikidata, which is more than 13 billion triples, the estimate is around 3.5 years. So it's a very wide approximation. It could be faster, it could be even slower, depending on how fast people are editing Wikidata. But yeah, that's quite a lot of time. So who will govern the next split? Well, it really depends on what's the best thing to split, or if splitting is even the best case scenario. So we've been looking into subgraphs, that's scholarly articles. Then the next one is, I believe, astronomical objects, which is 8% of Wikidata triples, and then humans, which is also around 8 to 9% of Wikidata triples. Then we're looking into vertical data, which are labels and descriptions. So descriptions are a lot. There are like 20% of all of Wikidata triples, so it's not a small number. So yeah, there are lots of other things to consider before we decide what to split off from Wikidata.
Maybe you can talk a bit more about these 50%, right? Because you looked at it and it's 50% of the triples as opposed to 50% of the items we have, right? So we have, I want to say about 40% of the items, but they just have a lot of statements on them and generate a lot of triples. Is that correct?
Yep, that's exactly correct. So the way a subgraph was defined is also not exactly black and white, just as Lydia was saying a bit earlier, that so for scholarly article subgraph, do we include the authors in the subgraph, or is it just the link to the authors? So at present, what the way we calculated the subgraph size was everything that is in within the item, any scholarly article item. So any specific scholarly article, all its statements, and every link to an author, but not the author item itself. But when we look into the author, every author is instance of human, so that would be included in the human subgraph. So that's kind of how we are kind of defining in a very rough way what a subgraph is. But definitely there are links from almost every subgraph to every other subgraph. So there's a huge amount of links from scholarly article subgraph to the human subgraphs, because, well, every article has an author who is a human. So we have a link over there. So there are a lot of links like that. And it's not just scholarly articles. There are other things like conference papers, abstracts, journal papers. I think the second largest one was review articles. But the reason we are focusing only on scholarly articles is because the numbers are really huge. It's so for scholarly articles, we have around 37 million items. And for everything else combined, maybe it's less than 100,000. So that's why the focus is mainly on scholarly articles. And plus, most of the other articles are also instance of scholarly articles. So a single item can be instance of multiple things, and when it's instance of scholarly article, we just include it in that subgraph. So yeah, I mean, looking at it from a very high level, scholarly articles do take up a lot of space.
Thank you. Cool.
Lydia, maybe you can say a few more words about the. I mean, there was a question. Like the initial question was about the governance model, and like the search platform team is very much on the technical level. The governance, how we edit the data, how we structure it, that's way outside of our domain. And Lydia, you might be able to shed some more light on that side.
I could try. Nice one. So, I mean, at the end of the day, the content in Wikidata is decided by its editors, right? And what I think we need to work towards is making it possible or easier or more binding to have these conversations about what should go into Wikidata and what shouldn't. Not in a sense of an exclusionist, oh, this is not notable enough for Wikidata kind of thing, because I think that's not very healthy, but in a sense of, is this data that is best kept in Wikidata itself as a baseline of data to work with, or is that maybe data that is better served by a specialized community in a specialized Wikibase instance that really thrives around that data and can maintain that data and can open up that data in a really good way. And that is not an easy discussion to be had or an easy decision to be made. And I don't think there are, unfortunately, easy answers. I think what is compounding the effect a bit with scholarly articles and also astronomical objects is that there are existing databases that are machine readable and can, I don't want to say easily, but comparatively easily be scraped and imported at scale quickly. And I'm not sure the same applies for other areas necessarily, which also gives us a heavy bias, right, in our data that is kind of, I would say, not very healthy towards stuff that's easy to import and easily available, as opposed to really relevant for the people who use our data to bring it to people and show it. Not to say that scientific articles aren't relevant, they are really relevant and important as a foundation for everything we do. So, yeah. I hope that gave a bit of an answer. I know it's not an easy and complete answer. Yeah. All right, then Shane was saying, I do want to be able to select all of the data that links to my items. That's the whole point of entering such data. However, I'm perfectly happy waiting a day or even a week or more for the result. My workflow never restricts me when Listeria lists fail or queries timeout. I have a whole family of Listeria lists that I wouldn't mind switching to bi-monthly updates from monthlies, for example. So yeah, this delaying query computation seems to be definitely a thing that's possible for a lot of the maintenance work also. Need heavier queries. All right. Yes. Mm-hmm.
No, that's definitely something we'll keep in mind when working on the future technical solution that we can or cannot put in place.
Yeah.
There was a missed question from Renat, I think. And I'm missing it again. Just to clarify federation between different Wikibase instances, will there be one wikidata.org based on one MariaDB and a few triple stores? We don't know what the future is like. There's no decision yet. There are ideas. My intuition, and that's not more than an intuition at this point, is that the model where we have only one wikidata.org based on one MariaDB is something that is going to be a problem scaling into the future. And that's what we're saying. Like, again, taking the example of scholarly articles, if we split that one to a different Wikibase with a different MariaDB and a different triple store, that's a model that probably makes sense in the future. That's not something I have the ability to change on my own. That's something that's going to need a ton of discussion thinking about how we can or cannot make that happen. And again, no decision is made. That's nothing more than an intuition at this point.
Cool. Then a question by Marco. Do you plan to support the Sparkle 1.1 service keyword in WDQS?
That question was answered, but the question after that is how does one get on that list of approved services? So this is a federation. Federation is enabled for Wikidata Query Service and for Wikimedia Commons Query Service. And usual process require. I'm not sure, Guillaume, if it's changed, but most recent I remember is creating a ticket for a new federation endpoint, right?
Right, then the next question I see, do you cache the query results so that same queries don't have to be run again as long as the data is the same? And do you think it's possible to look if you run a query again only for the new information since the date of the query ran before on another databases?
We do have a very short cache, HTTP level cache, and I don't know if it's 1 minute or even less than that, but so it does help if the exact same query is done a ton of time per second. The really hard problem is cache invalidation. It's a known hard problem in computer science. Cache invalidation is difficult. So knowing when to invalidate the cache because the underlying data has changed is a super complex and difficult problem that we're not going to be able to solve. It makes sense to have a short cache because it prevents like burst of the same queries from consuming resources on the back end. And then the next good thing to have would be letting the clients choose how much cache they're happy with. Like for some use cases, you don't care if the data is an hour old or maybe even a day old. But for some other use cases, you want to go back to that minute of delay at most. There is no good way to do that, at least not at the HTTP level. There's no standard around that. It's not something that's well understood. The next best thing after that is to let each client do their own caching because the client knows what they need. So like if you're writing an application or a bot or something on top of Wikidata Query Service, and you know that you're going to do the same request over and over again, and that you don't care about the freshness of that data, then it makes sense to implement a cache on the client side, but on the server side, probably not.
Cool. Then David asked, do you have statistics on how many of the queries are actually so complex that they need more than 10 seconds or something like that? Aisha, do you want to talk a bit about that?
Yeah, I just gave a link to an analysis Joseph had done earlier on query time analysis, so that would be interesting for people to look at.
And the short answer is that there is, and I don't remember the numbers, and Aisha is going to correct me, but most of the queries are extremely fast, and there are a few queries that are extremely expensive. And like one way of solving all of our scaling problems in terms of read load in the short term would be to move the timeouts from the 1 minute we have at the moment to even 30 seconds. We would remove, I don't remember how much, like something like 80% of the load on the service. Now the question is, the queries that we would kill in that context, they would probably be really painful for some people, and so that's not something we're going to do, but we have that bimodal distribution, response time distribution, where a few queries are taking way more resources than most of the queries on the service.
All right, do we have more questions? Jane is saying she has no idea what her query load is. If you told me, I would split the query. Is there an easy way for someone to find out how much load a particular query is causing?
So the full answer to that is no. And so there's no good way in Blazegraph to have the full cost of a query. And all the computation and the analytics we're doing is not on the actual query load generated by a query. It's on the time taken for a query to run. And that's a good approximation of the complexity of the query. So yes, there is a parallelism level behind it. We don't have any control over it, and we don't have any way to measure it. But if your query is responding in 10 milliseconds, you can assume that it was cheap. If it's timing out after 60 seconds, you can assume that it was expensive. So the time it takes to run is a reasonably good proxy of the resources you're eating up on the servers.
Can one of you maybe talk a bit about which type of queries tend to be less heavy and which tend to be more heavy?
I just wanted to add something to the previous question about how many queries take more than 10 seconds. So to the numbers, I've given a link to another analysis which has very clear numbers. So more than 10 seconds, the number of queries is less than 1%. It's exactly 0.6% of all the queries for a month. And they constitute 60% of the time, total query time required by Wikidata Query Service. So yeah, the thing that Guillaume was talking about, that most of the queries are super fast, only a small percentage of query, which is even less than 1%, constitutes 60% of the time. So yeah.
Just a quick note on the speed of the query. One thing that I see quite frequently is people running queries without a limit. So please don't forget to put a limit at the end so that you don't try to extract the whole subset of what you're looking for. This is often going to timeout and causing load. So that's just a small thing to just think about adding.
So in terms of optimizing queries, there's putting a limit on the number of results you're asking for. Are there other things that people can keep in mind that are easy to do?
I think we have fancy tools in the query service, like the service label and all that. They can be costly. So if you are a heavy user of the query service, I would advise you going straight to the information you need. For example, if you need labels, but you don't need labels for the query computation, but just for displaying, I would suggest using the Wikidata APIs to fetch the label back, for example, and just get out the Q item from the query service. And just focus on what you really need from the Sparkle engine, and everything else should be fetched from other services as much as you can.
Mm-hmm. Right, then the next question from Renat is, I remember there was a limit of 5 parallel Sparkle requests. Is this still the same?
I think we have throttling on every server. So if a single IP address is eating a single server multiple times in a short period of time, they will start to get throttled and banned over time. But I don't think we limit the overall parallel. I think at the Blazegraph level, we limit the number of threads, but not the number of queries in parallel.
And I was just going to jump back to what we were talking about before as well, because yesterday on Twitter, there was some discussion around a query, and I went and dragged some numbers up about the sort of speed it would run at. And the whole topic again was whether or not you were asking for labels or whether or not you could add them afterwards. And the query not asking for labels takes 3 minutes and 21, so it's still above the timeout, but that same query asking for all of the labels ends up with labels it takes 3 minutes and 21, and without labels, it only takes 15 seconds. And so that's sort of some of the scale that some of your decisions can end up changing in terms of how hard it is to run and return these queries.
I just want to point out that this is true for any federation query service as well. It's a network connection, and it will be take be time consuming. So another one thing is that you always should remember to limit the simpler queries and limit the number of incoming queries from the federation. It will be executed as a separate query on a separate service. So it's worth to do it before the data from the federated query comes back to your server, in this case Wikidata.
I just wanted to add to what Adam was talking about labels. It also applies to other sort of things. For example, if I ask for authors, there are a lot of articles with authors, but that's not really what I was looking for. I was looking for something else, and so it's by no error of the user. It just so happens that some predicates, some properties are used in a ton more items or triples than others, and so using those or asking, writing queries, asking for those triples takes longer and probably might run out of query time. So it's by no fault of the user. It's just that's the number of data we have. That's huge.
All right, we have about 7 minutes left. Egon is asking, what if we would add a unique identifier to a Sparkle query, not just a tool name? For example, a link to an issue tracker so that you can report the troublesome queries. Would that help?
I'm not sure I understand the question correctly, so I'm going to rephrase that so you can tell me that I misunderstood. What I'm understanding here is that if bots or users would not just add their tool names as a user agent, but have a specific identifier or specific bug tracker link inside of the query itself, I suspect as a comment or something like that. So that's when on our side, we're going through the logs, we're identifying queries that are problematic. We have a very easy way to report it to the owner of that query and work with them to improve it. And if that's actually what you're thinking, most of the bots, so the rule should be that if you're contacting the service, you should have a specific user agent that includes an email address or a way of contacting you. Most people already don't do that. If only just that would be done by all bots, that would be amazing. As long as we can connect in some way with the people writing queries, that's amazing for us. I doubt, like, the most problematic tools and bots are probably going to be people who are not well integrated to our community and who will probably not follow those advice anyway. But yes, it would be great.
I also want to point out that we take very little time thinking about banning generic usernames like one from Jenna or other tools. So if you forgot to change your user agent, it's very likely that we will be banning queries from those sources on any sign of trouble. In that case, this is very important for us to be able to see the source of the information, and it's better for everyone using our service as well.
Just wanted to point out that the bulk of the queries actually are very generic, have very generic user agents, and often no user agent at all. It was something automatically generated, like the browser name, etc. So yeah, I think that's very important if you want to manage everything nicely.
Then SJ is asking, can you quickly guess if a query will be fast or slow and have dedicated fast lanes for fast queries?
No, it's it's a hard problem. I mean, it's a machine learning problem. So I think someone, Wikimedia Germany, has already worked on that, trying to find what in the queries make the query heavy. But it's not like a proof or something, a rule that you can apply. It's just like speculation on the set of features. So
yeah,
no,
and
I don't
think
that
remembering something from all of that work, I think it was if it had the string IMDb in it that doesn't relate at all to actually what the query is doing, just somebody decided to name a label IMDb, then it's probably maybe possibly an expensive query. Yeah.
I'd like to know more about that work. Yeah.
Yes, I mean, I can share the slides with you. All right, then Dara's asking, is there a list of recommended requests the API should be used for rather than a query? There isn't at this point any good documentation for this, but being worked on because it is a useful resource that should help people to better make decisions on which tool to use for their requests. So. Then many comments. Do we have any more questions that I missed?
There is one about training a model based on history of a SparkQL request to get recommendation service for expensive queries. I think that something similar was actually done. That was the research we had, and it proved that yeah, if it has IMDb inside, that's a expensive query, not super useful for us. So yeah, we didn't. That was the actual research done. No luck, unfortunately.
And then Toby is asking, could the query request include a request for time that could help with scheduling and queuing? So you indicate in your query if you need it fast or not?
I don't want well, I don't want to commit into what we will be doing, but I think the solution would be more on the UI side, like what you can do on the query, for example. If you run a SQL query on the labs replica database, you have a UI that you put your query and then you can come back the next day. And it's not about tuning the parameter to help the system to work well. Just telling the system and having dedicated UIs that you can have a real asynchronous service.
All right. And then maybe one last question. Is it possible to set a timeout lower than 60 seconds?
No, not at the moment. And so that's another problem with Blazecraft. Blazecraft is so we do cut the queries over 60 seconds. They are still consuming resources for longer than that on the back end. So it wouldn't actually change anything in terms of resource consumption with the current backend that we're using. That is Blazecraft.
All right. Then I would say thank you all so much. If you have more questions, feel free to put them in the Etherpad or reach out to one of us. Yeah, thank you so much for all your questions and answers.